We are going to give you here a very short introduction to JavaScript. We are not going to describe the language in its entirety. We are going to focus on the aspects that we are going to use while developing for Py4Web. So to be able to write JavaScript code, we are simply opening here in the developer console, in the developer tools of Firefox, the JavaScript console. And we are just going to use it as a prompt where we can write a JavaScript code. So first of all, what are the data types? Well, the basic data types are strings like hello. You can also use single quotes. Okay. And you can also use the other type of quotes embedded in the quotes you're using. For example, it's night already. Okay. And this will work. You could also write these using single quotes to begin and end it. Okay, in which case you would need to quote the quote. It's less convenient, but you can do that for strings. Another thing you have, of course, are integers like 4, 5, and so on and so forth. You have floating point numbers, of course. You can express them also in exponential notation. Okay. And then you have a special type null, which is the equivalent of Python's none, roughly. It's used for when you do not have a value and you want to signal that there is no value there. Okay? You can declare variables in JavaScript, and there are two ways. One is to say, let x is equal to 2. Okay? And the other way would be to say, var a is equal to 3, okay, which also creates a variable. So what is the difference between these two definitions? Essentially, the scope of let is limited to the block of code that contains the let assignment, the let declaration. So anything from this opening brace to this closed brace. So if I now add here a line that says console.log of x, and I run this piece of code here, the result will be an error, and code reference x is not defined, because here, which is outside of these two braces, x is not defined. If instead, so I can comment out that line, and instead if I write here console.log of a, this will work. Okay, you see it outputs a 3, because the scope of this declaration, of a var declaration, is the entire portion of code that is in the same function, declaration, or in this case, all the top level code, because we are not in any function declaration. Essentially, var is the old way of writing JavaScript code, where the scoping was the function, and let is the new way in which we are using the scope according to the code block. There is a third thing you can do in JavaScript. You can use constants. So I can say const s is equal to hello, for instance. Okay, and if I do this, again, the scoping is local. So here if I do console.log of s, I will also get an error. Let's see. Yes. S is not defined. So const and let are the modern way of doing it. Const is for declaring constants, let is for declaring variables, and the scope is the code block. One special thing about JavaScript is that it tries to make your life easy by doing automated type conversions between variables, even though this sometimes leads to trouble. For instance, suppose you do hello plus 1, 1 is a number here. This converts automatically 1 to a string and concatenates it to hello. JavaScript is essentially reasoning, I don't have a version of plus that works for a string and an integer. So what I can do is that I can convert the integer to a string, and then I can add the two. Okay? So this gives rise to a common shorthand. You can add the empty string to a number as a way to convert the number to a string. This is somewhat horrible. If you had these into a variable, a better way would be to do a to string. Okay, and this would do the conversion in a more readable way than the hack above. Okay, this also leads to a few troubles. For example, imagine that you do 100 plus quote 1. What do you think the result will be? Well, it's the 100 is converted to a string, and then it's added 1. But if you do 100 minus 1, the result is 99. Do you notice the asymmetry between these two lines? And so this is a common source of errors in code. You may not be aware that this 1 is a string. You may think it's an integer, but it has been passed to you, for example, through some web interface or web method. So you don't know it's a string, and your code works when you decrement, but not when you increment another number. Okay, so this is an example of a strange thing that can happen. And of course, if you do a hello minus 1, this will give you not a value, indicating an error. The same helpfulness of JavaScript is reflected in how it processes a test for equality. Let's give you some examples. Empty string is equal to 0 string. This is false, so these are two different strings. But 0 happens to be equal to the empty string. Why? Because when you do this test, you try to convert these two to booleans, and both 0 and the empty string will be considered as value false. Okay, so you can also say, for example, that 0 is equal to 0, and this is true. Okay, then you can have false is equal to false. No, this is false actually. But false is equal to 0, and yes, this is true. Okay, and so you have these various peculiar behaviors. So the suggestion is that JavaScript offers, in order to keep your mind more reasonable, a triple equality operator. So you can do triple equality, and the triple equality disables the helpfulness of JavaScript in doing automatic type conversions. So for example, 0 will no longer be triple equal to the string 0. Okay, so essentially, and so you can, for example, say that false is not triple equal to 0, to the string 0. Okay, so the type conversions that happened above, for example, in this case, are disabled in this case. So essentially, remember, when you do equality comparison in JavaScript, the double equality, which was the traditional equality, tends to have strange effects. It's much better to rely on triple equality that asks for equality without the help of implicit type conversions. You have if-then-else constructs in JavaScript. For example, you can say let C is equal to 25. Well, and then I can write if C is greater than 100. Okay, console log too expensive. Okay, else if C smaller than 10, you can say console log too cheap. Okay, and you can conclude with a final else that says console log sounds good. Okay, so if you execute this code, you will get sounds good, because 25 is between these bounds. The conditional operators work as you would expect, so you can say for greater than 3 and this evaluates to true. You can say for greater than 3 or 6 smaller than 8, this evaluates to true as well. What is important to notice is that in the JavaScript, like Python, uses cheap evaluation of these Boolean operators. So if the first alternative is true, the second is never evaluated. For example, I can replace the 6 smaller than 8 with a console log of hey, okay, and if I evaluate these, the result will be true because this already evaluates to true. Okay, the AND is written as in C with a ampersand for greater than 3 and 1 is smaller than 0. This will evaluate to false, of course. And the not is simply an exclamation mark, so I can say not 4 is greater than 3, and this will give me false. There are loops. For example, I can say let n is equal to 4, and then I can say while, and then give a condition n greater than 0, and the loop body can be n minus equals 1, so this will subtract 1, and then I say console.log of n. Okay, and so the body of the loop will be executed as long as n is greater than 0. So if I run this code, I get 3210. Okay, once I decrement n and n is equal to 0, I still log the value, but then I stop. There are also for loops that work with a syntax that is very similar to C's. So you can say for let I is equal to 0, I smaller than 5, I plus plus, okay, and then I can say console log of I, and if I run this code, I will get 0, 1, 2, 3, 4 as I expect.